Hello, Honors Algebra 2, and welcome to the Chapter 3 Challenge. This challenge here is rather interesting in that these problems are called linear programming problems, and they really encompass all of what we did in Chapter 3. I'm going to go through an example here with you. If you take finite math, you'll be doing this again, but this is a nice way to kind of encompass everything we've done. And please note that you will be kind of learning this on your own. I'm going to challenge you to do so and to try a problem out. They're not terribly difficult, but they are new. If you need an additional example, it can be in your textbook, so that could be helpful. So work together, challenge yourselves, and let's give it a go. So example 1, the Allen Theater. All right, we sell matinee tickets for $7 and general admission for $9. Now in real world, you hope to make some money from movies, and in this particular weekend, we're hoping to make at least $630. That at least should ring something in your mind. We'll get back to it later. In order for a movie distributor to allow them to continue to show a movie, there must be at least, hey, there's that funky word again, 150 tickets sales, either matinees or general admission. The theater itself can only hold a maximum of 200 guests, and so that's between matinees and general admission. Okay, all these different things, if you're thinking of them, are known as constraints. Okay, so create a system of linear equations that represent the different constraints. Constraints we have are that, okay, they want to make a certain profit, they need to have a certain number of guests, and the theater itself has size restraints, okay? There's other types, but this is just a general problem here. So the best way to go about this is, hey, create a system of linear equations, more like inequalities, that represent the constraints. First off, let's, of course, let our variables be our things here. So we're going to let x be our two things, matinees, and we'll let y be general admission. Okay, with those things in mind, we can begin to create our first constraint here. I'll use colors to help you out. Movie tickets for $7, general admission for $9, at least $630. What that means is we have 7x plus 9y, at least means greater than or equal to 630. That's the first constraint, the money, okay? Our second constraint from the red information, general admission and matinees must be at least 150. So x plus y must be at least 150. Theater itself can only hold a maximum of 200 guests at a time. Okay, what that means is, so we only have 300 seats or 200 seats, which is very big. But in general, what that means is if people are coming to the matinees, x is going to need to be, so a maximum, x needs to be less than or equal to 200. Similarly, y must be less than or equal to 200. So there's some others. All of these we call our constraints, okay? Just another thing to note, for linear programming, we always consider x and y to be greater than or equal to 0. These problems always deal with real-world things typically, so most of the time you can just assume things are greater than or equal to 0. We can't have negative movie showings or anything like that. So with those with those created, we're going to graph them. Okay, I picked some nice ones here to graph. Here is where I would recommend the old intercept model. You could solve for y, but I would represent the table model. So the table x and y define the intercepts 0, 0. This is for the blue constraints of our money. So again, if we substitute 0 in for x, we have 7 times 0 plus 9y greater than or equal to 630. Essentially 630 divided by 9. 70. So 0 for x is 70 for y. Vice versa, 90 for y, or 90 for, sorry, 0 for y is equal to 90 for x. Okay, so those are 2 points on this axis. I should have enough here to plot those. 0 up 70. Please be careful with these, 50, 60, 70. This is the point 0, 70. 90 to 0. And we'll use a solid line, connect those, and there you go. Okay, shading. Okay, these are inequalities, so you do need to shade. And let's just consider we would shade everything above this line here because it is greater than. So I'll just draw general arrows here to represent what's going on. Okay, everything in that direction. The next one, x plus y greater than or equal to 150. So make the table 0, 0. Well, that's just easy, 150 for each. 150, 150. We're going to close that one off with a line. And this one again is everything above the line. Okay, so with shading, we're going to want everything where everything is shaded. Okay, last two, x is less than 200, y is less than 200. Please remember x is a vertical line. So vertical at 200, right through here, whoops, I'm going to do this, and it's less than, so in this direction, and y is less than 200, cutting off here, and less than everything in this direction. Okay, so all of our shading comes into one area. That comes out to be this shape here. Okay, that's where all the shading lies, and that's where our solutions will lie. So any combination in here will appease the theater, will appease the movie distributor, and everything like that. Any one of those work. Okay. Now, more specifically, though, a linear programming problem is going to have an objective function. So that's like your first part. Now, the second part is, okay, if the theater makes 35% off matinee sales and 25% off general admission sales, what combination yields the most profit? Okay, so as an equation, we would have profit is equal to 0.35 of the matinees, which is x, plus 0.25 of general admission, which is y. What to plug in there to find out? Here is the neat thing. For objective functions, you're going to substitute in all of the corner points. The corner points are all of the corners of our shape. We have a few of them. So we have this point here, that's a corner. There's another corner. 3, 4, 5. Labeled out, this is the point 0, 150. This is 150, comma 0. This is 200, comma 0. This is 200, comma 200. And this is 0, comma 200. That is where the maximum or minimums lie. Nowhere in between, but one of those corner points. What you want to do then is take those corner points and substitute them as x and y into the profit. So you have a few ones to try out. 0, 200 is the first one to try. So if you plug in 0 for x, 200 for y, 0.35 times 0, I'm just going to show you this, plus 0.25 times 200 gives me the profit, essentially just 0.25 times 200. I would make 50 bucks. Okay, try out another one. So we can try out 0, 150. Well, even in your head you might be thinking that's going to be less because it's just essentially 0.25 times 150. Okay, 0.25 times 150 is going to be 37.5. You can try all the other points, okay? If something in your mind's like, well, wait, it only makes sense really to tap out here at 200, 200, you can certainly try that one. So let's just jump to 200, 200. Okay, that would be 0.35 times 200 plus 0.25 times 200, x and y. And that profit is going to equal $120. Okay, that's how much they would make. If you tried out these other ones, so just for example, if you tried out 200, multiplied that 0.35, you would only get 70. And if you tried the 150 times 0.35, you'd only get 52. Okay, so I only think that's the only problem, really. I mean, that's the idea. You graph everything, make the constraints, and find the corner points, plug them into an objective function. Okay. Your challenge then is to try a problem very similar. Again, you could do it together. This one's dealing with soft drinks and popcorn. So graph the constraints. You can do it together. You should come out to nice numbers for this. And there should be an objective function. There it is. I'll make sure it's on the same page for you guys to solve. When you're finished solving, you can turn that in, and I'll explain to you what that will earn you as far as a grade and other things go. So good luck. Thanks for watching. Again, use your textbook if you need some additional examples, and good luck.